Now let's start with part C, the last part, data pre-processing for complaint analytics. Now the first question asks about to discuss accuracy, completeness, and consistency issues, missing timestamps, contradictory narratives, mistyped sections. Also propose to more quality dimensions relevant to legal analytics, uh, timeliness, verifiability, etc. Now, what is accuracy? Does the data reflect reality? For example, mistyped IPC sections or incorrect spelling of names. What is completeness? Is all required data present? For example, missing timestamps, witness details, or blank evidence fields. What do you mean by consistency? Is data uniform across the database? For example, contradictory narratives. Text says daytime, field says 22:00 p.m. Uh, Timeliness. How quickly is data available post-incident? Delayed FIRs are often scrutinized more heavily in legal context. Verifiability, provenance, ability to trace data to its source, for example, FIR versus physical log entry. Now coming to the second question, for handling missing values in structured features, discuss approaches, ignore tuples, manual completion, constant fill, mean, median, mode imputation, class-specific imputation by offense category, most probable value, model-based. Ignore the tuple. Delete the entire complaint, viable only if the data set is huge and missing data is minimal. Otherwise, valuable legal precedents are lost. Manual completion. A legal expect reviews uh, and fills blanks. High accuracy but very low expensive. Uh, Global constant. Fill with unknown or -1. The algorithm might mistake this for a real pattern, causing misinterpretations. Central tendency imputation. Fill with mean, symmetric data, or median, skewed data of the attribute, maintaining statistical distribution. Class specific imputation. Use median value of complaints in the same offense category. For example, median loss for theft cases. Most probable value. Use regression or decision trees to predict missing values based on other available features, leveraging existing data relationships. Now, coming on the third question, which discusses about smoothing extracted scores, use the evidence strength list from A2. All right. So the A part talks about data smoothing using bin means, bin depth 3. The original sorted rating from part A, question 2, is the sorted data given here. Resulting bin means bin 1, 13, 15, 16, mean is 14.67, and bin 2 mean is 18.33, then mean is 21, then 24, then 26.67, then 33.67, then 35, then 40.33, then 56. The original data is smoothed by replacing each value within a bin with its calculated mean, reducing noise and highlighting general trend. Now moving on to B and C part of this question, outlier detection and other smoothing techniques. For detecting outliers, box plot rules suggest values above Q3 plus 1.5 multiplied by IQR, or below Q1 minus 1.5 times IQR are flagged as potential outliers. A Z-score, that is data points with a Z-score greater than 3 or less than -3, are considered outliers. Contextual detection in this legal DSS. Uh, a high impact combined with low evidence is a specific outlier that might indicate a false or exaggerated complaint requiring deeper investigation. Now, data integration challenges in legal DSS. Schema integration, combining data from diverse sources like EFIR databases and physical station logs. The key challenge is mapping different field names, time of incident versus occurrence time to a unified global schema, and handling redundancy, identifying duplicate entries where the same crime might be reported in multiple ways across different systems. Solution can be correlation analysis can detect if one attribute implies another, reducing redundant features and ensuring data parsimony, resolving conflicts when merged records present conflicting information. For example, when a source states a loss of 50K and another 5K, solution can be prioritize sources with higher provenance. For example, a verified physical evidence log over initial FIR text, or use voting averaging mechanism. Now coming to the fifth question, which talks about normalization methods for feature scaling. Let me see that. Yep. Uh, Min-max normalization linearly transforms data into a fixed range, typically 0 to 1. Uh, while it preserves the relationships, it is highly sensitive to outliers, which can distort the scaling. Now, Z-score normalization scales the data based on its mean and standard deviation. Values represent how many standard deviation they are from the mean, uh, making it effective when min or max values are unknown or extreme. Z-score with mean absolute deviation (MAD), similar to Z-score but uses MAD instead of standard deviation. This method is more robust against outliers because deviations are not squared, reducing their disproportionate impact. Decimal scaling moves the decimal point of values of attribute A. The number of decimal points moved depends on the maximum absolute value of A, simplifying numerical representation without altering relative differences. Now coming to the sixth question, binning case severity scores. The bin scores are 5, 10, 11, 13, 15, 35, 50, 55, 72, 92, 204, 215, which gives the number of given values as 12. Now equal frequency, equidepth, divide into bins with the same number of items, p bins of 4 items. Bin 1 gives a set 5, 10, 11, 13. Bin 2 gives 15, 35, 50, 55. Bin 3 gives 72, 92, 204, 215. Equal width range equals 210 with 3 bins with 70. Bin 5 to 75, 5, 10, 11, 13, 15, 35, 50, 55, 72. Bin 2 76 to 145, that is 92. Bin 3 146 to 216, that is 204 and 215. Clustering bin. Utilize algorithms like k-means to group numerically close values, naturally separating low severity cases from extreme outliers like 204 and 215. Implications. Equal frequency ensures a balanced workload for magistrates, while equal width can disproportionately assign values to categories like petty crimes, leading to imbalances.